Hey everyone, so let's suppose we have this problem here. So as you drive in your car at 15 meters per second, I'm going to underline that, it seems like it'll be important, just a bit under 35 miles per hour, that seems like redundant information. You see a child's ball roll into the street ahead of you. You hit the brakes and you stop as quickly as possible. So you come to a stop. In this case, you come to rest in 1.5 seconds. How far does your car travel as you brake to a stop? So I circled how far because that looks like is what we're solving for, how far. So we're solving for our displacement in this problem. All right, so I'm just going to start listing what I know and what I don't know. And looking at this problem, when I hit my brakes, we're going to have a constant acceleration, right? So that means we can use the kinematic equation. So in terms of variables I'm going to list initial and final position, initial and final velocity, time, and acceleration. So let's see. Well, actually, I should probably first draw a diagram, shouldn't I? So here's my car. It's driving along a street. Maybe we could list our initial and final positions on our diagram here. And our car is going to be driving off this way until it comes to a stop, right? So here is when we first see the ball, that's our initial. And then our final is when we come to a stop. Right? So in this case, it's going to be very useful to call our initial position 0. Our final position, we don't know, and that's actually what we're solving for. So I'm going to circle that just to remind myself that's what I'm solving for. In terms of initial velocity, we know initially we're driving at 15 meters per second. I wrote down a number without indicating whether it's positive or negative. So since our car is initially moving to the right and coming to the stop, let's call to the right being our positive x direction. So our initial velocity then is a positive value. In terms of our final velocity, we know our final velocity, we're going to come to a stop. So we're not going to be moving, so it's going to be 0. Now in terms of this, let's see. If we know how much time has elapsed between these 2 points, that'll be useful to note. And we do know that, that's 1.5 seconds. And if we knew our acceleration, that can also be useful. And it looks like here we don't know the value for acceleration, so we'll put a question mark there. All right, so looking at this, we have 3 kinematic equations to choose from, right? So we've got our velocity equation. So our final velocity is equal to our initial velocity plus acceleration multiplied by time. We've got our position equation that states our final position is our initial position plus our initial velocity times time, plus 1/2 times our acceleration multiplied by time squared. And then we have our no time equation that says our final velocity squared is equal to our initial velocity squared plus 2 times our acceleration multiplied by our displacement. So every single one of these equations has acceleration in it. Right? So if I'm thinking that I want to solve for position, I might think, let's go to the position equation, right? Well, our position equation has our final position being an unknown as well as our acceleration. So we have 2 unknowns in one equation. So that has an infinite number of solutions, so we can't solve that. So we need to find our acceleration first before we solve for our final position. So then let's look at our other 2 equations, right? Well, this equation over here, again, involves both acceleration and position, so 2 unknowns. So we have to go to our velocity equation. Let's just check first to see if we have enough knowns. So our final velocity, we know that's 0. Initial velocity is 15. Acceleration was what we're solving for, and time we know is 1.5. So we can solve for acceleration there. So kind of the process I like to go through when solving a problem. So first I'm going to write down my equation. So we're dealing with final velocity is initial velocity plus acceleration times time. Always write what equation you're starting with to begin with. This way, whoever is grading your assignment, whether it's me or if it's an AP grader on the AP exam, they know you know what you're doing and not just randomly plugging in numbers, right? So here's our equation. I'm going to now plug in any zeros, right? Well, we have said that our final velocity, that's 0. Everything else here is known. All right, so we have 0 is equal to, our initial velocity plus our acceleration multiplied by time. So now I'm going to rearrange this, solving for time. So you have negative initial velocity is equal to acceleration times time, and now divide both sides by acceleration. By time. What am I doing? I am solving for acceleration. I apologize, you guys. I literally just woke up and it is 5:30 in the morning, so. All right, so we have our equation for the acceleration, and it's negative initial velocity divided by time, right? So if we can plug in numbers. So we have a negative, our initial velocity, that's 15 meters per second, divided by our time, 1.5 seconds. So 15 divided by 1.5, that gives us a negative 10 meters per second squared. So let's check if our answer seems reasonable, right? So kind of looking at our number, this says that for every 1 second, our car is going to slow down by 10 meters per second, and that seems like a reasonable rate, right? So that numerical value seems reasonable. We have a negative sign, and since our velocity is moving to the right, since we're moving to the right in our positive direction, if we're slowing down, that means our acceleration has to point in the opposite way, in the negative direction. So that makes sense too. And in terms of units, we have meters per second divided by seconds, that's meters per second squared. So our units make sense. So I think we're pretty good with this acceleration value. So then now that we have this acceleration, we can then actually go of two ways. We can either use our position equation to solve for a final position, or we can use the no time equation. Either one is fine because we have enough variables to solve for either. I'm going to use the position equation just because I don't have to, there's less things I have to rearrange, right? So I'm going to show every step. So I'm going to start with my position equation. All right, plug in my zeros. Well, so my final, I don't have any final velocity, I just want to plug that in. My initial position, that's 0. And everything else is a known quantity. So my final position is going to be, so I'm going to start plugging things in here since I don't have to rearrange. So we have our initial velocity, multiply our time, plus 1/2, and you want to show this step. And I say this because sometimes on the AP exam, they don't give you credit for whatever final formula you have or something like that. They might, or whatever final number you have, they'll give you credit for plugging in the correct values. So if you accidentally make a calculator error, you'll get full points by showing you're plugging in the correct numbers. Okay, so please be sure to do that. By do that, I mean, besides not plugging in the correct numbers, but I mean, show the formula, rearrange it, and then plug in numbers. All right, plugging in acceleration. My acceleration is negative 10 meters per second squared. Don't forget the negative sign, very important. Right? Otherwise, it would have been if we hit the gas instead of hitting the brakes. Need to multiply by time. Multiplied by time, 1.5 seconds. And we square that quantity. Don't forget to square it. Very easy to forget to square that. So in solving this, I'm going to grab my sticky note where I have my spoilers. Our final position when plugging this all in is 11.25 meters from our origin. Right? So how far, that is a scalar quantity. Right? It's not asking for a displacement, so we do not need to indicate direction. So there is our answer. So it takes us 11.25 meters to brake.